math people. Today's math question is, how do we get the law of cosines? So the law of cosines is a formula that's used to solve oblique triangles when given certain information. So what I have here is an oblique triangle. So oblique meaning not a right triangle. And I'm going to develop the law of cosines with this oblique triangle. Now the law of cosines is probably going to deal with cosine of some angle. Cosine is a trigonometric ratio that deals with a right triangle. So therefore, even though this is an oblique triangle, I'm probably going to have to construct a right triangle to do what I need to do. So prior to doing that, as you can see here, I have the angles labeled capital A, capital B, and capital C. I'm also going to label the sides opposite of these angles with the lowercase respective letters. So by that I mean I'm going to label side A with a lowercase a, opposite of angle A, side B with a lowercase b, opposite of angle B, and side C with a lowercase c. Now I'm going to do some things with side B, so I'm just going to do this just to illustrate that side B is all that. Now I need a right triangle, and I'm actually going to create two right triangles by drawing a line perpendicular to the base AC. So here you can see I have two right triangles, both of which I'm going to use. And I would like to label the bases of these two right triangles with different variables. So the base of this triangle, let me just call it x. So the distance from here to here, I'm calling that x. Now remember, the complete distance from here to here is b, correct? So if all of this is b and this is x, so that means the part that's left would be b minus x. So this is b minus x here. Again, if all of this is b and this is x, what's left would be b minus x. Alright, so for the law of cosines, we probably need to do cosine of one of these angles. I can't do it with angle b because angle b has been chopped up, but I have choices of a and c. I find it more appropriate to take the cosine of angle c. So I'm going to take the cosine of angle c. And before I do that, I need to label this side that I just created because that's part of these right triangles. And since it's perpendicular to the base of the triangle, it's appropriate to call it the height. So I'm going to label this side h. Now I'm doing a cosine of angle c, and cosine is adjacent over hypotenuse. So for angle c, the adjacent side is b minus x. And the hypotenuse is a. And I'm going to take this and just algebraically solve for x. So I'll multiply by a, multiply both sides by a. I'll get b minus x equals a cosine c. And then if I move the x over here and move cosine a over here, I'll get x equals b minus a cosine c. Okay, now even though this is a law of cosines, I'm actually going to use a sine ratio to find this formula. And I like to keep the same angle that I've been using. So I'm going to find the sine of angle C. I'm going to find the sine of angle C. Sine is opposite over hypotenuse. So the sine of angle C would be h over a. So sine of C is h over a. And if I solve this for h, just multiply both sides by a, I'll get h is a sine c. Alright, so notice I have expressions for x and h. To find my formula, what I'm going to do, it's a very elementary rule that you know, is I'm going to do the Pythagorean Theorem on this right triangle. I'm going to do the Pythagorean Theorem on this right triangle. As you know, the Pythagorean Theorem is the sum of the squares of the legs equal the square of the hypotenuse. So that means that x squared plus h squared should equal c squared. So x squared plus h squared equals c squared. Now, this doesn't give us a whole lot right now, but remember, I have different values for x and for h. So I'm going to plug in these values for x and for h and do the Pythagorean theorem, do a little algebra, a little trigonometric identities, and see what happens. So I'm going to take these values for x and for h. I'm not going to change c, because the formula we're actually doing is a formula that will be used to find side c. So I'm not going to change c, but I'm going to change x and h. So again, x is b minus a cosine c. So x squared would be b minus a cosine c squared plus h squared. H is a sine c, so that would be a sine c squared equals c squared, of course. So now from here, we're just going to do a little bit of algebra, apply some trigonometric ratios, and we should be on our way. Alright, so I need to square this. I'm squaring a binomial. So the formula I'm going to use here, you may be familiar with, is like a minus b squared, which is a squared minus 2ab plus b squared. So consider this a, even though that's a b, and consider that b. And so if I square this guy, I should get b squared minus 2ab cosine c plus a squared cosine squared c. So that's the expansion of this one. This one is just a monomial, so I'm just going to square both terms, plus a squared sine squared c, and all this should equal c squared, of course. Okay, so now let's see what we have. Here you may notice that both of these terms have an a squared in them. So I would like to factor the a squared out to see something that happens. So I'm not going to change anything here. B squared minus 2ab cosine c. And again, on these next two terms, I'm going to factor out an a squared. And when I factor out the a squared, I'm left with cosine squared c plus sine squared c. Cosine squared c plus sine squared c. And all that equals c squared. So I think you can see why I wanted to factor out this a squared, because there's a Pythagorean identity in trigonometry that says cosine squared theta plus sine squared theta equals 1. So cosine squared c plus sine squared c is going to equal 1. And a squared times 1 is just a squared. So this is going to become 1 times a squared is just a squared. So what I have here, I have an a squared, I have a b squared, and a minus a 2ab cosine c. And all this equals c squared. I'm going to put the c squared in front. C squared equals, and now I'm going to write, just going to put the variables in alphabetical order. So a squared plus b squared minus 2ab cosine c. And there you have the law of cosines to find side c. In most textbooks it's written as c squared equals, but since we're actually solving for c and not really solving for c squared, I like to write the formula as c equals the square root of a squared plus b squared minus 2ab times cosine c. Now that's just the formula for c, of course. And we can follow a similar procedure with that triangle to find for sides A and sides B. But to save time, you'll watch what happens. So C is the square root of a squared plus b squared minus 2ab times the cosine of c. And what you'll notice, there's three sides in the triangle A, B, and C. You notice the side that's here, you find the other two sides here, and the angle that's opposite of this side is the angle that we're taking the cosine of. So we probably can figure that if we're finding side B, then it's going to be the square root of a squared plus c squared minus 2ac times the cosine of b. If you don't believe me, draw another triangle, do the same procedure, and check it and see if you get this result. And similarly, if I'm doing a, then it's probably going to be the square root of b squared plus c squared minus 2bc cosine a. So let me put times cosine a, so these two c's don't double. And let me put times cosine b here, so those two c's don't look like they're double. And just say consistent, let me put times cosine c there. So there you have, ladies and gentlemen, the law of cosines.